So I'll start by saying this is kind of a very cheesy title, and I realize, especially here in Berlin, you have a very positive hacker culture, so essentially this, but that's a very long title. So my point being, when you talk about reverse engineering, stock photo website pictures, this is what happens when you search for hacker. This is what happens when you search for malware analysis. These fantastically cheesy images, which I absolutely love. Especially this guy with his balaclava on to use his laptop, probably because he doesn't want to put tape over his webcam, and he's trying to find a CD-ROM drive on his MacBook. It's good luck. And this guy, which apparently this is malware. If only it was that easy. But yeah, so you get a lot of this kind of stuff when you talk about reverse engineering. Essentially that the idea is that it's for malicious purposes, or maybe it's for trying to stop malicious purposes. So the point I'm kind of wanting to make here is that actually it's something that all developers should do a lot more, because it's actually useful for a lot more than that. So why should we take things apart? This is a CMS detector at CERN, and it's designed to see a range of particles and phenomena produced from high-energy collisions. Firing protons at great speed, smashing things apart to see what they're made of, to see what's underneath. By the way, these guys do open days, and if you get the chance, this is well worth going to see. But basically, the point is, if we want to understand how things work, we take them apart. Maybe it's to fix it. Maybe we just do it for fun, just for an illuminating educational experience. And that's for everything, whether it's cutting edge of science or if it's, I don't know, disassembling a washing machine or something. It's how we learn how things work. So maybe you want to know why an app uses a specific permission. For some reason, this Notes app wants access to my contacts. Why does it need this? I've got a photography app, and for some reason, it wants the ability to send SMS. What's that for? Maybe this app is crashing. You're running an end preview. You're a developer, and some app is not working. You like this app. You want it to work. And maybe you don't want to wait just submitting bug reports and saying, doesn't work, because you're a developer. Maybe you can actually help. Maybe you could submit more info. You can get this fixed sooner. Or maybe it's your app, but you've used a library, and that library is, maybe it's an ad SDK or something like this. You don't have the source code for this library, and the code quality on these libraries is not always the highest code quality that you could find. So you might be able to find out why that thing is crashing, figure out a workaround so that you can use it in a different way. Maybe, yeah, as I said, it's not your app, but it's crashing on your device. Maybe you're running a custom ROM and that's causing it. Maybe you just want to know, you see something cool, and you just want to know how they achieved that. It's got some fancy little visual effect, or something, it does something that you actually thought was kind of in the realms of magic. Somehow they managed to use the camera API and make it work on a Samsung device, or maybe you're just trying to choose a library. You're not sure whether you want to go for this implementation or this implementation. There's like 15 different libraries to choose from for this same thing. You could have a look in the Play Store, look at some successful apps, see which ones they use. People don't tend to talk about their complete library list, but if you reverse a lot of apps, it's actually trivial to see which libraries they're using, and that might inform your decision. So essentially, you're not pulling these things apart so that you can steal their code, but just because you're writing your own, it doesn't mean that there's not a point to having a look at how somebody else did it first, and you can learn from that. So hopefully I convince you. So the first thing you want to do is get the APK off the device. It's pretty straightforward. This, for instance, is a nice little one-liner that will list all the packages that have been installed. The 3 stands for third party, so it basically means installed on the device. And it will tell you the file paths for them. That's what the F does. And then you could easily pull one of these back with something like this little one-liner. It's a bit messy, I admit. This is largely because ADB line endings and stuff, and it has to basically convert them. It's kind of fiddly, but this could pull you, given a package name, that would pull the APK off of your device. So it's a nice, easy way to just pull it onto your computer, and then you can start having a look. You could also get them from various other sources. There are places on the web where you might be able to download an APK, but do bear in mind that if you do this, does this conform to the terms and services of your agreement with the Play Store and all this kind of stuff? I'm not a lawyer. And secondly, if you're downloading APKs from shady websites, maybe don't run that on your phone. You're kind of asking for trouble. Like, there is no real guarantee. You could check the certs and so on, make sure the signatures are okay, but without taking extra steps, there's no real guarantee of what's in that APK and that it is the legit one. So do be careful. So I would suggest, honestly, the easiest way is just pull it off your device. So you pull it onto your computer. You want to have a little look at it. First thing you probably want to do, AAPT. This thing is part of the Android SDK. You already have it on your machine. If you've developed apps, if you've even played around with the emulator or whatever, you've got this. And this tool does a heck of a lot. It's got like, it's actually, this is all the kind of stuff it does. It's loads and loads of stuff. But this is the bit of interest if you're wanting to have a look at an app. Just as a quick kind of initial thing, what is this app? What does it do? What permissions has it got? Etc. So with this tool, you can dump things out of the APK. This is the thing that kind of put them in. This can pull them out. So you, like what? You could dump the badging. This will basically give you the kind of initial info you might want to know about the app. Just give you a kind of an overview, what permissions it has, what activities and so on, how the thing is kind of roughly put together. It's a top-level view of the application. Tell you the configurations, permissions, and so on. You could dump the strings from your application. This is actually kind of fun. You grab a bunch of APKs from the Play Store, dump their strings. Some of the things you'll see that people don't really think about the fact that they're just there. This stuff is readable. With a simple little command, it's very readable. So maybe if you're using a private key for your API or something, have a thought about how easy it is to dump these strings and, maybe take steps to actually obfuscate that stuff just a bit. You can view one of the binary XML files that's been packaged into the APK very easily with this. So for instance, this will dump the manifest. And so on. This tool is very versatile. So you've got a lot of stuff in an APK. In case you don't know, many of you probably do, but I'm just going to quickly run through this. In the meta-inf directory, you've got the certification signing stuff. So basically, you can use this if you've got an APK from a third party to see what the signatures, the certs are, what it was signed with, and verify that versus an official APK and make sure they're the same and so on. There's also interesting that you can put a whole bunch of stuff in here that then doesn't get included in the signature. Some malware users takes advantage of that. You've got the manifest, which, although it says it's XML, it's binary XML. Hence, you would have to dump it to actually read it. If you've got the resources, which is basically just all compiled into one big file. You've got your resources that are not compiled. So if there's any that are not bundled into that bundle, then you'll find them in there. You've got an assets directory. This would, well, to be honest, this could be all kinds of things. And actually, again, is somewhere where some malware will package things that look like images and so on, where it's actually dynamically loaded code. You can put kind of anything in here that you don't want to be processed. Most of interest to us, really, this bit. Classes, .dex, obviously the Dalvik executable bytecode. When you're putting APKs onto your device nowadays and you're installing them, obviously there is some, pre-compilation that's happening. Obviously we've gone towards doing that up front with N, and before N, and then with N we're kind of stepping back from that a little bit again. But either way, you basically got this Dalvik bytecode there, whether it's what is being used or not, depending on how it's compiled. This is essentially the code that's running. And finally, in the lib directory, you've got your native code. I'm not going to go deep into that because reverse engineering native code is a whole other level of stuff, and this is pretty much just kind of casual, easy stuff to look at. So, and finally, other. This is also very interesting because sometimes you'll find you grab an APK from the Play Store or something, open it up, and you'll find some files in there. You might find a file from a developer's machine or, just random stuff that was just left around in the build directory when the APK got created. And all sorts of stuff sometimes ends up in here accidentally. So it's worth having a look at your own APKs, just make sure. So how can we start to look at this? I used to use something like this, which I wouldn't really recommend as a way to do this nowadays. This is way out of date. But it was just, kind of unzip the thing, run a bunch of different tools on it, things like dex to jar. And so I'm kind of pulling out the dex to jar stuff to get a kind of a Java jar, but it's actually not ideal. Back Smiley on Smiley to kind of pull out the Smiley, which is like the Java assembly, if you like. And just kind of get something in various forms to just have a quick look at. But to be honest, nowadays, this thing, APK tool, probably a lot of you heard of it, used it even. This will do all of that. It does all of that. In fact, I'm going to give it a better entrance because it's pretty amazing. It's pretty great, right? So what does it do? So for instance, if I just run that, just one line, simple little, the D stands for dump, I think, on an APK, then bingo, it will do all of that. There we go. I've just got all the same stuff. I've got the manifest, I've got the resources, I've got the XML stuff, I've got the, back Smiley's running here, so it's pulling all the Smiley out of the dex. So just as an easy, quick little way to have a look at what's inside an application, this is like your first step. It's simple. Sometimes it has trouble with APKs that have been processed in a particular way. Maybe they were packaged up with a custom build of AAPT or something specifically to make them harder to reverse. There are ways and means around that, but to be honest, most APKs, if you just want to have a little look to learn something, this will probably work. So you could use this, for instance, just as an example, some of those questions I said earlier, like how's this thing done? I see on this application, they've got a nice little thing in their layout. It's got a nice little round kind of image. And what are they doing to do that? Oh, well, okay, look, here's the layout file. And I see they're using a rounded image view. Okay, great. That's the library they're using. Cool. Maybe I'll just go use the same one. I'll see if it's any good. That answers that question easily without me hunting around and trying to find a library that does it, or trying to implement it myself when they're actually just using a library. Maybe I want to have a look at the code. Admittedly, this code is not the best thing to look at, but it could be enough to answer your questions. This basically is as I said, it uses Smiley and back Smiley, so it's reversing this stuff, but it's reversing it to essentially Java assembly code, which is not the nicest thing to read, but could be enough. Like, you probably don't want to do an extensive amount of programming in this, but you can maybe quickly see how they're doing something. There are better ways if you actually want to look at Java code, which I'll get to. But it might answer your question. Maybe I just want to see why this thing was crashing, or I want to be able to debug this app. This won't always work, but it's worth a shot. You can basically open up the app like this, rebuild it, re-sign it, and you can rebuild an app so that it's actually debuggable on a normal device, like as in not just on your rooted device or emulator or whatever. This would mean you could put it on any old device, and it's actually now a debuggable APK. And now I could run it and attach a debugger. And I can use the Smiley that the APK tool dumped out as the source code of the app, because it has line numbers and things, and it is possible to step through this. I could set breakpoints and, yeah, dynamically analyze the application. Next tool I'm going to mention, AndroGuard. Now, if APK tool's good, this one is amazing. So, even more spectacular entrance. This is essentially, it's not one tool, it's a collection of tools. They're all, it's Python-based, it's a whole bunch of little scripts that all just do one thing, do it really well. So yeah, it's kind of modular and all sorts of things plug into this. There's a bunch of tools that use this, provide a GUI on top of it or whatever. It's also got this really cool little thing, an interactive Python shell, or IPython shell, that's the script Androlyze. And you can use this to kind of browse around inside an APK and have a look, which is quite cool. It's got auto-completion and so on. And it's got a Dalvik decompiler built in, which means you're not using things like dex to jar, which, yeah, great early on when Android was pretty new. It's a way to do it. It was trying to convert it into Java code. But we're not dealing with Java code. We're dealing with Dalvik code. And the bytecode is different. So it's worth using a Dalvik decompiler, not a Java decompiler. This thing has one built in. It's pretty good. The site, honestly, it looks like the tool's not maintained anymore. But if you look on GitHub, you see that this gets commits still. It's still kept up to date. So basically, you use something like this. You can just run this, and this will start an interactive shell. So you'll get a little prompt. And as I said, this has like tab completion and everything. So I can run something like this, and this essentially will analyze that APK I give it. I can also pass in things like dex files to this or various other formats. And this will produce a few kind of results, like these three objects here. And basically those three objects are, we've got like one file that represents or one object that represents the APK, the original APK that I passed. One that represents the actual Dalvik, like the dex, the stuff inside. And then one that represents kind of a metadata object that's got a whole bunch of just interesting stuff on it. So for instance, I could take the first one and just say, well, what's the main activity on this APK? And it will tell me that's the main activity. I could say, okay, in the dex file, I want to look at this class. This is the path of the thing. And as I said, you can sort of do tab completion here. So you can kind of go com, tab, example, tab. And I could just ask for the source, and it will, on the fly, just decompile that and show me Java, or you can do basically Smiley or Java from this quite easily. And you don't waste time decompiling the entire thing. You just browse around and basically look at the little bits you want to look at as you want to look at them. And because you're there in Python, you can script all this stuff, which is kind of fun. And it's also just got some general purpose kind of functions, like you can say, well, show me the permissions of the app. So this is like, if you like, the sort of Java doc, not the Java doc because it's Python, but the documentation for this method. It will show you the permissions in an application. This is a bit hit and miss. Like if you try it, actually kind of gives you a whole bunch of stuff here. But basically the idea here is, for instance, I might say, well, look, the read contact is being used where it's accessing a contact contract. Now, maybe this, like this bit is kind of obvious, but this gives me some kind of idea where I can maybe go, the class I might want to start looking at if I want to see why that permission is being used and what it's being used for. Some sort of entry point. And I can do a whole bunch of other stuff. It's a very good tool. I highly recommend it. Talk a little bit about some other tools, because there's a whole bunch of tools here, but I don't want to go too much in depth in all of them. Classy Shark, obviously, this is a relatively, recent-ish kind of addition. From actually, well, it's the Google-supported one now. It's a real official thing for having a look at your APK. And it does a bunch of stuff for you. It's got a basic GUI there. It actually can also be used from the command line, which a lot of people don't necessarily use it from the command line, but you can plug this thing into your build, for instance, if you want to keep an eye on something like, well, actually there are other plugins that will tell you method counts and things, but it can do that and other stuff as part of your build. It can be used from a command line, so it's kind of useful. It's scriptable. And it's very easy to just open up your APK with this again and just have a quick look. Obviously, one of the things that's usually recommended for is looking at the like dex method counts and so on, what libraries are big and so on. But it's a nice, easy way to browse an APK and just have a quick look, see what's there, what the package structure is. And it can open an incredible amount of things. You can pass this in dex and AAR, like your libraries, even native libraries, and it will, like the SO files, and it will actually show you information on those, which is kind of cool. So yeah, this is, you know, it's free, it's pretty easy to use. This is a useful tool to have. Code Inspect was actually presented here, I think, a couple of years ago or a year ago. And it's a work in progress thing, it's an academic thing. It uses so I mentioned like Java assembly and formats. This one uses a slightly different one from the one that most things use. A lot of things use like Jasmine. This uses Jimple, which is just another way of viewing decompiled Java code. And that's because it actually uses this thing called Soot, which is a static analysis framework which has been around forever. And it builds upon that, adds lots of little tools and analysis things on top of it. It's good because basically it's an IDE. Essentially, you can debug an app and you can perform runtime analysis on it. And as you navigate around, and these are usually very premium features you find, you can start to rename things and change. You know, as you start to understand the application. The only downsides, I would say, it's based on the Eclipse framework because it's a nice, easy way to build a kind of IDE type thing, which, you know, not my favorite thing. And it is an alpha thing at the moment, and basically you just have to write them an email or something, say you want to evaluate this thing, you want to try it out. I don't know what plans I've got for how it's going to be used in future, but it's worth having a play with, and they're very kind of interested, I'm sure, in hearing from people who are interested in it. Yep, that's Code Inspect. What else have we got? This is an interesting one because it will run on your device. You can have this on your phone. The UI is a bit basic, but it started out as a hex editor and ended up this massively scriptable framework for reverse engineering. And it supports lots of architectures like x86, ARM, etc. Again, it's one of these tools that's actually much more broad than just for Android, but therefore is useful for this too, and can be run on your device, you know, not just on your desktop. It is open source again, so you can go check out the source, contribute, whatever. And as I've said multiple times, actually, it will run on your device. It's portable. It's kind of useful. It's on the Play Store. And there are a whole bunch of other apps that are on the Play Store. Things that will just very simply just kind of, you can give them an APK. Some of them are a little bit old, like JADX. I don't know how that's exactly supposed to be pronounced, but it still kind of works. There's another thing, Show Java, which actually will use that other app to do the decompilation, or it can also use CFR, which is a popular Java decompiler. There's Dexplorer. This is another app. You can just browse around if you just want to have a look at the APK's assets and so on. So particularly if you root your phone or anything like that, then basically I'm not suggesting you do root your phone, by the way, I'm not endorsing that. But if you do have a rooted phone, then you can just on your phone go and open another APK and have a look at it. It's kind of cool. And this is a popular distro of Linux, which is used for a lot of sort of security-based stuff and reversing type stuff. You can get an ISO for this, and you can boot this as a virtual machine. But to be honest, also just looking at their it's a bootable Ubuntu light version of Ubuntu Linux environment, and it has all these tools just pre-installed, which is kind of nice. You don't have to spend ages downloading APK tool and AndroGuard and all the rest of it. But also, just if you look at the tools that it actually comes with. That's essentially a good starting list of what tools you might want if you want to start playing around and opening up APKs, they're all installed on this thing, so that's the list of stuff you probably want to get if you don't want to run this distro. Finally, there's also, if you're kind of rich, there are things like IDA Pro, which has been around forever. This thing it's called the Interactive Disassembler, and this thing, it goes way, way back. It's more known as a general reversing kind of tool. It's very expensive, but it has like a fully featured disassembler and debugger, and it's always supported loads of stuff, x86 type stuff, but it actually supports Dalvik since version 6.1, and so you can use this on Android apps. But you probably have to be kind of serious about it to start using this, because it is a commercial product and it's not particularly cheap. This one also Jeb, or now Jeb 2. Similarly, it has a Dalvik to Java source decompiler that is their own proprietary one, and can do interactive decompilation and navigate and rename things and so on, which is kind of nice if something's obfuscated and you start to make sense of it. And this, similarly to IDA, this can debug Dalvik code and also native code. You can kind of go into each. But again, this is a commercial thing and subscription, so if you have the money and you're very interested. So that's a whole bunch of tools. But hopefully there's some useful stuff in there. And I probably should address security just a little bit, because if you're talking about reverse engineering, that's kind of necessary. It's kind of the counterpoint. So obviously, I've said several times how easy it is to open up these apps. You go on the Play Store and get the top 10 apps and open them up, and most of them, actually, you'd be surprised, a lot of them aren't even obfuscated, which is fantastic, because it's a really good learning opportunity. It means you can go and you can see how these apps are built. You can pretty much read their source code, which is fantastic. If you're wondering how to do something, that's kind of my point. You should go and look at this stuff, but in an entirely legal way. I'm not a lawyer, but basically, the funny thing is, it's really not that hard to, at the very least, turn on obfuscation. And to think about security. A lot of people don't think about it at all. You finish building your app, put it out there, done. But you kind of need to ask yourself, is there anything in your app where you don't want someone to be able to find that thing out? Because, what basically needs to be a secret, and how secret? Is it sort of the level of, it's a key to use our API, but we don't really care if someone pulls out the key and starts using the API, because we'll quite easily be able to spot those ones and we'll just block them. That's fine. Okay, maybe we're not too fussed. Maybe we'll just put it in the app, but it's got a very basic obfuscation. If it's really, really super secret, honestly, it shouldn't be in your APK, because if it's in there, it is possible to get it out of there. So if it's something that really has to be very secret, it should never leave your back end. It's not something that should be packaged into your application and sent out there. This is always kind of a trade-off thing, and it always comes down to how much effort you want to put into securing something versus how easy it's going to be for someone to pull it out. So you don't want to spend forever and ever obfuscating the hell out of the whole of the structure of your application, because it's going to make development difficult, it's going to make maintenance difficult, and it's going to take a lot of time. And if it's not that important that if anyone opens up your app and has a look at it, then let them. They're going to learn from it, so it's great. But maybe just take the most basic steps you can just to basically protect things if it doesn't take any effort on your part. So, for instance, turning on things like, essentially would be ProGuard, but now, it's just kind of classified as general minification and obfuscation within the build process. It's very much a first-class citizen. It's something you probably should switch on, unless you have some really good reason not to, because it's just there and it just works. It's easy. But also, interestingly, look at what it does, because most people just switch this on and then that's it. Forget about it. I switched it on, it built. cool, it must be fine now. And I won't look at the output, and I won't see if it's doing a good job, which I will show an example of in a moment. If you are, pushing a commercial product and you really do have stuff in there that you'd rather people couldn't look at quite as easily, there are things, other tools you can use, like this DexGuard. It costs, but this is the guy who wrote ProGuard. They know what they're doing, and DexGuard understands Android apps, whereas ProGuard was just originally for Java. So this thing can do a little bit more for you. It can obfuscate things a little bit more and make it a little bit more tricky for people to open up your application. Particularly things like it obfuscates resources and class names and uses characters that wouldn't necessarily be valid with the standard Android SDK tools, which means that you try and open these things up and everything just blows up. Which is, it uses various devious tricks like that. And you've got SQL Cipher, which is kind of wraps your database and encrypts that stuff. There's a whole bunch of these tools. Again, it kind of just comes down to scaling to what you need to keep secret and how secret. But crucially, do actually look at the results of this. If you're paying, especially for something like DexGuard, or even if you're just turning on basic obfuscation and minification, look at the output. Open it up, grab AAPT, dump your strings from your own application that you built. See what's in there. See if there's anything in there that you wouldn't want people to be able to see that easily. Or see if there's your package structure is actually kind of ruined by your obfuscation isn't doing its job. For instance, this is an obfuscated app, but you can kind of see like everything about this app, even though, sure, I've turned all class names into A, B, C, D, E. Great, but they're in a package called preview. So I pretty much know what these all relate to. And I can see that this feature is where the services live, and this is where the settings are in the splash screen. This isn't very hard to navigate at all. It's got obfuscation switched on, but the obfuscation, the whole benefit of it is kind of undone by the fact that, and this is actually a very popular way to arrange your apps, packaging things into packages by feature. And honestly, I like that organization of applications. But maybe think about putting things that are going to be obfuscated separate from things that are not going to be obfuscated. Because if I need to preserve the whole name of this activity here, this class name and its entire package, then everything along the way to it has to be not obfuscated. So now everything in this package is clearly in that package, and I can navigate this very, very easily. It kind of just undoes the whole purpose of obfuscating it. And this is why I say it's about just basically looking at what your obfuscation does or any of the tools that you're running and just seeing if they're really doing their job. And if you're happy with that. I mean, this could be very easily fixed by just putting, say, all the activities into an almost identical package structure, but just separate slightly. Just one name different on their package structure. And then basically this wouldn't happen. This is very easy to avoid, but you wouldn't know unless you actually reverse your own apps. So it's worth having a look. As I say, yeah, you can group these things into a different structure, which might be a mirror structure, but it's just alongside. So have a look. What else have I got? Just finally, a few other useful bits and pieces. This book at the top, this is a fantastic book about all this kind of stuff. I highly recommend that. I didn't write it, nothing to do with me, but it's a very good book. This was a talk that was actually given here last year, Dismantling Droids for Breakfast. This was fantastic. Another talk that was given at DEF CON about reverse engineering. And finally, the documentation on AndroGuard is very good. It just kind of gives you a good guide of how to use it and all the things you could do with the tools. It's very versatile, so there's a lot you can do. And it takes you through everything pretty well. All the links will be in the slides, so don't worry too much about trying to get the links from there, because obviously it's a bit difficult to get the URL off of that. And yeah, if you're interested, then that's a bunch of stuff you should probably have a look at. So I think that's about everything. Yeah, cool. Thank you very much.
Jon. Thank you for this very insightful talk. Did it leave any questions open? If so, ask them now and raise your hand. Do I see any raised hands for questions for Jon? Yes.
Hey, Jon. I have a question. If I'm a casual hacker, what I mean by that is sometimes a UI designer comes to me, shows me, oh, that's a cool application. Oh, and this interaction is pretty fun. Make it for next week. How hard should it be, right? So which tool is like for me? So, or should I test every single tool until I get the result?
Yeah, so essentially these ones, the ones I mentioned particularly at the start, I mean, I listed a whole bunch of other tools just because they're worth mentioning, but the ones that I really kind of showed more detail of there are because I think those are the ones that give you the most for very little, and hence my kind of showing the one-liner type things for those, because it's just, you know, it's like, dump this, and you just, everything, it just opens it all up. You can then browse around the resources, the code, everything. So essentially, AAPT is usually my first stop to just say, what is this app, what does it look like? And then beyond that, it's APK tool to just quickly dump it all out into a directory structure I can browse around, or it's AndroGuard if I want to know something really specific and want to just poke into that bit and have a look at the source for that function. But like APK tool, I say, it kind of just lays it all out flat for you to have a look at and see the layouts and that kind of stuff. So usually if I'm copying an effect for something, you know, like it's like, we saw this thing in this app, we want to do that. I would open it up with APK tool, have a browse, and maybe use AndroGuard to just peek at very specific bits and get a better decompiled version of certain functions or so on. So yeah.
Any more questions for the mighty Jon? Oh, yes.
Hello, Jon. It's like with security in a car or something like this. How much effort to spend on your stuff, and how much not if you want a feature from another app, with the development of an app? You can either, if you have, let's say, 1,000 hours for the team, in a sum, you can either make as much as possible, and then it's unsafe, or it can be disassembled, whatever, or you just spend 50%, and the app looks awful, or it's not satisfying the requirements, even with agile development, and then it's a little bit more safe. So where's the time is always a limit.
Yeah, absolutely, and it depends on your individual use. What you know, if I'm building an app for banking or Bitcoin or something, financial, I really care about security. You know, that's a big deal. But if I'm building an app that, I don't know, allows me to share pictures of my cat, then who cares? Like, honestly, you know, if someone reverses that, they can see how it works. That's okay. I'm really not that fussed. Like, it's fine. There's a different level for everyone depending on what you need to keep secret. But I guess my main point is that the very minimum steps that take no effort, really, and you just have a look at what they do and just make sure they're doing it right, those take no effort, and you should just do them. Like, it's straightforward.
That was it? Yeah, that was it. Thanks, Jon.
Cool.
Thanks again.
Thank you.